Hello everyone, I hope you're having a good day. In this lesson 1.10, it talks about modeling with functions, and it takes some things that you already know from previous courses as well as what we've already studied in chapter 1 and combines it all into applying it to real world word problems. There's no rigid step-by-step procedure to construct a function from a verbal description in this lesson. You really have to just read carefully based on what you're given, recall prior information, and then, of course, try to write a critical sentence that describes the function's conditions in terms of your independent variable, which is usually x in these cases. And then once you can create a verbal description, then you translate it into algebraic form. These problems you may be dealing with linear functions or nonlinear. We'll get to some quadratics, and this lesson is very, very important in the study of calculus, because in the study of calculus you learn how to find the minimums and maximums of functions, maximize your profit, or you want to minimize the area that's contained in a certain region. Or if you are in production, you of course want to minimize the cost by minimizing the surface area of your container for your products that you produce. And we're going to look at some examples of that. The first example that we're going to look at, and in all of these problems, it's going to give you, of course, certain condition, then it's going to tell you to express your information as a function of something in terms of x. If we're looking at choosing between texting plans A and B, and number 1, plan A has a monthly fee of $15 with a charge of 8 cents per text. Plan B, monthly fee of $3 with a charge of 12 cents per text. In part A, it asks you to express the monthly cost of plan A, and we're going to say that the monthly cost is going to be represented by f as a function of the number of texts in the month x. So they actually already define your variable for you. X is representing the number of texts. F is your function in part A, or it represents the cost of plan A. And in part B, you're going to be asked to express the monthly cost of plan B, and they're going to let that be function g as a function of the number of text x. So notice the x is the same in both cases. However, plan A is represented by function f, plan B by function g. In part A, if I'm wanting to express that as a function f of x, cost of plan A in relation to the cost of the text, notice in plan A you have a monthly fee of $15. So if we go back and read and try to decipher the information that we're given, if you ever see a flat rate like this in a particular problem, that is usually going to be represented by a constant value, or always actually will be represented by a constant. Then notice that in plan A, we have 8 cents per text. When you see 8 cents per text, 8 cents per feet, if you're buying carpet, $3 per square yard, hardwood flooring, paint. Well, usually, of course, paint comes in different gallons, but if you're wanting to try to buy paint to cover a large portion, then of course you're going to figure out the square footage that you need to paint and then figure it out from there. So we have this flat rate, so $15 plus the 8 cents per text x that you pay. Per means multiply. And so this, or you can say 0.08 to represent 8 cents times text plus the flat rate of $15. Then in part B, express the monthly cost of plan B, G. So let's go look at what plan B's information contains. It has a monthly fee of $3. And it also has 12 cents per text. And they said to let this be function g of x equals, and we're going to say 3 plus 12 cents per text. So that's the answer to part A and B. And then in part C, it says, for how many texts will the cost be the same? So I take the cost in function A. I'm going to take the $15 plus the 8 cents per text from function A. And I'm going to take function G, $3 plus 12 cents per text. And we're going to see where they come out to be the same. So anytime you're asked something like that, always set your two equations equal, and then we're going to solve for x. So once you get your variables together on both sides and all your constants together on one side, then we have 12 if I subtract 3 from both sides. And then I'm going to subtract 0.8 from 12. You get 0.04, and then of course divide 12 by 0.04 to see how many texts your cost will be the same. So when you've sent 300 texts in either plan, that cost will come out to be equal. Now what you need to know that is very important, as you've learned slope-intercept form in the past, y equals mx plus b, you've really never dove into the deeper end of it to actually see what your slope and what your y-intercept represent. If I wrote this in slope-intercept form, this would actually be your 8 cents per text plus 15. 15 would be your y-intercept. 0.08 would be your slope, and it's positive. So this actually represents the average rate of change for your price. So that's just saying that for every the cost is on average rate of change is 8 cents per text, and then 15, your y-intercept always represents your starting rate. Okay, another type of problem and I pulled a lot of these from your math lab assignment. Number 2, on a certain route, an airplane carries 8,000 passengers per month, each paying $100. A market survey indicates that for each $1 increase in ticket price, the airline will lose 100 passengers. So we've got, on average, 8,000 per month passengers, and they each pay $100 currently. A market survey showed that if you increase the ticket price even by $1, that the airline will lose 100 passengers. In part A, it asks you to express the number of passengers per month as N and a function of the ticket price X. So what we have to do, we know that right now we have 8,000 passengers on average per month. But if the ticket price goes up, then that's going to make it decrease by 100 passengers. And they tell you that X represents your ticket price. So the first thing we're going to do, X equals your new ticket price. So that's where you always start off with exactly what you know. I know that X is definitely my ticket price, and your price increase. The price increase is going to, of course, make, you've got some original, so your new cost of the ticket price minus your original. So that's the next amount of information that we know. All right, next, it also says that if my ticket price does increase, then I'm going to lose 100 passengers on average. So then the passengers lost due to that price increase would be 100 times x minus 100. That's just the passengers lost because they have this new ticket price. The original was 100. So this total represents the new price, and this is going to be the revenue that they lose. So finally, we're going to say the n of x, the number of passengers of function x, the new ticket price. You had 8,000 original passengers. But then if this is the case, you're going to lose 100 passengers times the ticket price that they increased it to. So we're definitely going to have 8,000, but we're losing this many. And let's go ahead and simplify that as much as possible. So 8,000 minus 100x plus 10,000. And then combine like terms. So the number of passengers is 18,000 minus 100x, or you might see it written as negative 100x plus 18,000. And of course what that means in relation to slope-intercept form is that your number of passengers is decreasing on average of 100. So notice that it definitely has a negative slope. All right, part B says to express the monthly revenue R as a function of the ticket price. If this represents the number of passengers that you have, and your new ticket price, we've already said, was X. So remember, X was the new ticket price. And then we know that the number of passengers is negative 100x plus 18,000. And of course, revenue is money per person. So let's take and multiply these two together. So you're going to say the amount of people times the amount of each ticket, and then distribute. So revenue is ticket cost times the amount of people that you have. So negative 100x squared when you multiply those, and then plus 18,000x. Okay, the next part asks you to recall some geometry formulas. This is where we go into looking at companies that are producing material and minimizing or maximizing certain areas of it. I've listed all the two-dimensional formulas here for you, as well as your three-dimensional formulas for you. Square, rectangle, circle, triangle, trapezoid, all of those, rectangular prism, cylinder, so on. Number 3 deals with volume. A machine produces open boxes, meaning that they don't have a top, only the bottom and the sides. It produces open boxes using rectangular sheets of metal measuring 15 inches by 8 inches. The machine, so it's 15 by 18, but the machine cuts equal size squares from each corner, which I have drawn here to show you. Then what it does is it shapes the metal, so it just takes these side flaps and folds it up into a box. So if you've ever received clothes in a box at Christmas and you take the lid off, you've just got that. That's what it would resemble, is that bottom box. So we don't know what this is. This is represented by X. Like all of these, we don't know what that distance is, or length rather, that they cut off. So I'm going to say that part's X, this part's also X. Part A asks you to express the volume. So recall the volume of a rectangular prism or a box is length times width times height. And it's always in units cubed. So my units in this case are inches. So it just says volume is in inches cubed, which we know it will be. We're going to express the volume as a function of the length of the side of the square cut from each corner, X, in inches. So that's a lot of words. What they're wanting you to do is take this volume, represent it by your length, width, and height, all in terms of X. All in terms of X. Okay, since we know that we're cutting out, and I'll draw this a little bit better to show you, so let me take these off real quick. Alright, so we're talking about volume of this piece. Okay, I've cut this part out, and I've cut this part out. And we don't know. It just says they cut equal size squares. So they didn't tell us what length they cut off or what the measurement is of that piece. So what you have to do, 15 we're going to say is your length. 8 we're going to say is your width. And I want you to think about what the height will be. So if you imagine taking this flap and folding it up, it's going to be X. Your height will be X. But we want to represent the length and width and the height all in terms of X. So we've already got the height taken care of because it is X. But let's look at the length. The whole entire length would be 15 inches. But notice that you took an X length away, and you also took another X length away from the bottom. So you only have actually this length of your original. You subtracted an X portion up here from the length, and you subtracted or cut off an X portion of the length here. So we're going to represent this length as 15 minus 2x, because you took an x off and you took an x off. So 15 minus 2x is your length. And in the same sense, on the width, you took an x measurement off here, and you cut some x measurement off from that side. So 8 minus 2x is your width. But they want us to express that in terms of its volume. So we're going to say v of x, express it as a function of x, so make sure you write it in function notation. V of x equals length, which is 15 minus 2x, times width, which is 8 minus 2x, times the height x. And you'll be happy to know you don't have to FOIL that out. You can just leave it as such. So we're good there. You actually want to leave it unfoiled so that you can answer other parts of it. Now, in part B, they ask you to find the domain of this function, meaning what are all the values of x such that your volume will be positive and never will go negative. And what you do is you take each value, each factor. So I take 15 minus 2x, I set it equal to 0. I take 8 minus 2x, and I set it equal to 0. And then x equals 0. But I want you to think about this common sense. They're asking you, what can all the values of x be? You know that if your volume is 0, well, of course, you don't even have a box. You would have a two-dimensional figure. So we definitely know that for volume, it's got to be greater than or equal to 0. Okay, so x is greater than 0 is one part. All right, that's one part of my domain. So I'm gonna need that. I will need that in a minute. Let's go ahead and solve this and see what this value gives you for x. X being 7.5. Okay, well, I want you to check that. Is there any particular spot where we can plug 7.5 in and get a negative value? Yes. So if we plug in 7.5 here, we know it definitely has to be, it can't equal 7.5 because that would make it 0. But we would determine if it needs to be less or greater than 7.5 beyond that fact. But I want you to look right here. If we plug in 7.5, then I'm going to get 14, 15 point something, so on. I'm going to get a decimal that's greater than 8. So if I plug in 7.5 here, I get a negative value. Volume can't be negative. No such thing. So we rule that part out. Now let's check this part. So we get negative 2x equals negative 8, x equals 4. If I plug in 4 in this area, of course it's positive. This area, it's positive. 4 works here. 4 gives me a positive value in all parts. But then you need to think, can I be greater than 4? You can't be equal to 4. Okay? So I know that any values from 0 to 4 are in my domain. So you can say it in two ways. This is set builder notation. You can say x has to be less than 4 but greater than 0. Or you can put it in interval notation and say it's from 0 but we don't include it, and to 4 not included. And once again, the reason it has to be less than 4, well, we've already established the fact that if I go over 4, go to a value higher than 4, I get a negative volume, and that can't happen. So we're trying to figure out what are the only values of x that I can plug in any of the 3 places and I get a positive volume. And that only happens from any real number from 0 to 4. 0.75 will work, 1.999 will work. So that's how you determine volume. You solve it like setting each factor equal to 0, and then you have to check, well, can I be over that number or can I be under that number? I can be under the values of 4 or less than the values of 4. And we always know, of course, volume has to be greater than 0. So 0 was actually a factor itself, but I have to be, I mean to put the equal to part. So I have to be greater than 0 and less than 4. All right. Okay, the next part deals with manufacturers needing to use the least amount of material for containers that are required to hold special types of volume. To save on production costs, manufacturers need to use the least amount of material for containers that are required to hold a specified volume of their product. The least amount of material comes from minimizing your surface area, and you will study about this a lot in calculus. So if you're planning on going into a mathematical track in college or in the calculus next year, and of course then beyond mathematically, you definitely need to pay attention to everything that we talk about in this lesson because it's incorporated a lot. A cylindrical can is to hold 1 liter, which is also equivalent to 1,000 cubic centimeters of oil. They want you to express the surface area in centimeters squared as a function of its radius r in centimeters. If you'll recall, the surface area of a cylinder is 2 pi r squared plus 2 pi r h, where r and h are radius and height. Okay, so when they tell you that a cylindrical can is to hold 1,000 cubic centimeters, that is talking about volume. So they're saying the volume is 1,000 cubic centimeters. Don't get tripped up by the 1 liter. Notice that the rest of the problem tells you to express everything in centimeters. So make sure you use that unit. All right, notice the area has an R value and an H value, but they only want us to express the area as a function of the radius only. So they're telling us to do away with H. So you don't want H according to your directions. You do have volume. They give that to you, tell you what it should be. And if you'll recall, the volume is pi times radius squared times height for a cylinder. So then we're going to take our volume and we're going to plug in for V. And we're going to solve that. Take your volume, plug in for V. We're going to solve this formula for H. That way we are eliminating H and we can plug in, and then we're going to plug that in for H above. All right. So here's our step 1. Volume was 1,000. So I'm going to set that equal to pi times radius squared times height. Solve this for H. So 1,000 divided by pi times radius height. That's equal to H. All right, step 2. We are going to plug that in for H into the area function. So 2 pi r squared plus 2 pi times radius. Plug this in for height. We got 1,000 divided by pi times radius squared. And simplify that as much as possible. So we have 2 pi r squared. Notice in this case your pi's cancel out, and you have this r will cancel with 1 r down here, and you're left with 1 r. So then multiply straight across 2 times 1,000, and then all you have left on the bottom, and remember you treat 1, like 1's in the denominator here, so 1 times r, r. And that's as simplified as you can go. So there's your area expressed all in terms of are. But you had to use the volume information they gave you and use that to solve for H, so you can plug in. Okay, the next type of problem, I'm going to post a Word document, and this is just like number 8 on your homework as well. The directions in this problem say the sum of two numbers is 76. So the sum of two numbers is 76. So I'm just going to use X and Y. They tell you to express the product of the numbers P as a function of one of the numbers X. So as a function of X. So they're telling you, in other words, to eliminate Y. Okay, what you want to do here in this case, since we have this given information to us, X plus Y equals 76, we want to solve this for Y since they're telling us to leave it in terms of X. Solve for Y, so we get Y equals 76 minus X. Then, since I know that Y is equal to that, and I have X as one of my numbers, this is also Y in terms of X, so then they're wanting me to take the product. So I say X times 76 minus X, and that's equal to P of X. That was the product as a function of X. And then they go further and actually distribute. So you'll have 76X minus X squared is your product as a function of X. So once again, you had two numbers, X and Y. And we know that they have a sum of 76, so we use that information to solve for Y and get it in terms of X, and then we can take the Y, which is also that, multiply it to that number X to get one product in terms of one variable. Number 6. Okay, your directions here would say you have 400 feet of fencing to enclose a rectangular field. So we have, well, your problem in your homework, this problem in your example says we have 650 feet of fencing to enclose a rectangular field. So we're trying to enclose a rectangular field. And you have to determine, am I dealing with perimeter, area? What am I talking about? So anytime they say fencing around an area, that's always perimeter. So fencing around some type perimeter. Express the area of the field, however, as a function of one of its dimensions, X. So we're wanting to take what we know about perimeter, but then we're wanting to express the area in terms of that as a variable X. So the first thing you have to do is recall what you know about perimeter, and then, of course, see what you're given. Well, I know that perimeter is 2 times length plus 2 times width for a rectangle, and they do tell me that I've got 650 feet to use to enclose this rectangular field. Now, I'm going to let L and W actually become X and Y, since they tell me in the directions to express the area as a function of only one dimension, X. So let's say that we interchange that, and I'm going to say this is 2X plus 2Y. So then the next step, we need to actually solve for Y so that we can plug in. Okay, so we get 650 minus 2x, and I'm going to go ahead and divide it by 2, and that's going to give me y. Notice that 2 will divide into both values, so you can go ahead and actually simplify that further. This will be 325 minus x equals y. So I'm going to need that in a minute. So that's my value, that's my dimension. That's actually my dimension for width in terms of the length. That's all we did. I replaced my length with x, my width with y, used what I know about perimeter to solve for the width. So this is just actually your width in terms of length. Now we take that, then I plug both of those in for the area equals length times width. And then I'm just going to say x times 325 minus my width. And then distribute. So your area in terms of one of your dimensions x is 325x minus x squared. And of course that is in feet squared. You also have a problem in your homework, just like number 18. So it says a piece of wire is cut. A piece of wire is 8 inches long. The wire is cut into 2 pieces. So if it's 8 inches long and it gets cut, then one of the pieces has a length of x. The other one is 8 inches minus the length of the other piece. So that's how they're getting x. You cut some length off x, so the other length must be 8 minus x. Then it goes on to say that each piece is bent into a square. So they're taking this piece and they're bending it into a square. So they're taking some length x and they're making 4 equal sides. They're taking some length 8 minus x, bending it into a square, making 4 equal length sides. So that's how they're getting the 8 minus x divided by 4. They take this, split it into 4 equal sections to make a square. It says to express the sum of the areas of the square as a function of the length of the cut. So as you'll recall, area of a square is side squared. Then you just simply multiply those 2 sides together. So the area in this case is going to be x squared over 16. I just multiply my numerators together, multiply my denominators. The area of this square is going to be the numerators multiplied together, 8 minus x squared. You don't have to FOIL that in this case unless you want to. And then denominators. So, and they say express the sum of the areas. So we had to figure out the area of each, and then written as a sum, x squared over 16 plus 8 minus x squared over 16. Notice in their answer, I don't know if you can see this, but they actually chose to write the numerators all over the same denominator since they have it in common. Okay, next type of problem, we're going to look at 48. 48 asks you 6x squared plus 26x. All right, 48 says to express the area of each figure as a function of one of its dimensions x. Well, they actually make it pretty easy for us here. Well, kind of. They only give you one variable, so that's good. All we have to do actually is figure out the area of each piece we're given and then add them all together. So let's look at the blue triangle down here, and let's start there first. Now, a lot of you are going to work these a lot different, and so we'll see how you progress from there. All right, for the blue triangle, I'll show its work on this side. Notice that this entire length is 6x, and this length is 4x. So that means that this length here must be 2x. Does everyone see that? 2x plus 4x is going to give you the 6x. So we can go ahead and find the area of the blue triangle by saying 1/2 base times height at the bottom. So take the 2x and the x plus 2 and multiply those together. I'm going to go ahead and take 1/2 of 2 and then, I'll show you. Let's go ahead and take 1/2 of 2 and get rid of the 1/2 and the 2. So then we're just going to be left with x plus 2 times x. So once again, I just took 1/2 of 2, got 1, and 1 times the rest of that is that. And then let's go ahead and multiply that together. So x squared plus 2x. Okay, so there's the length of the blue triangle only. Now let's look here. Notice that I can split this. I want to show you something. I'm going to split it this way because I noticed that this length here is 2x. That means this length straight across from it will also be 2x. And that means that this length here will also be 2x. So I'm going to go ahead and find the area of, we'll say the orange figure. So the area of that rectangle, I'll call it 1, area of rectangle 1. Its width and length are 2x and x plus 2, so we're going to say 2x times x plus 2. And that's going to give me 2x squared plus 4x. And then let's do the area of rectangle 2. I've got 2x, its width times length of x plus 10. So that gives me 2x squared plus 20x. Last but not least, let's look at the area of the green triangle on top. Notice that its base is x, its height is 2x. So we can say 1/2 times base times height. Once again, I'm going to go ahead and take 1/2 of 2. And then I'll be left with x times x. So that equals x squared. Last but not least, they wanted you to write the function's equation for the area as a polynomial in standard form. So a polynomial in standard form simply means you put your terms in order of their individual degree. So in other words, I'm just putting it in order from highest exponent to lowest. So let's just start with the purple and let's write them all together and then we'll combine. So we got x plus 2x. And then let's go to the green, plus x squared. And I have plus 2x squared plus 4x for the orange. And then I have 2x squared plus 20x for the pink. When you write all of that together, let's go ahead and look at combining like terms, which is your last step. So I got x squared plus x squared plus 2x squared plus 2x squared. That combined gives you a 6x squared. And then combining your other like terms, we have 2x plus 4x plus 20x. And that gives you plus 26x.